Hello, everyone. You might think this motor's life is over, gathering dust in a corner, but I'll show you how to give it a completely new, powerful purpose, capable of picking up your favorite shows. I'll begin by taking apart this old fan motor. I'm using a screwdriver to remove these screws, ensuring I don't damage any internal wiring or the structural integrity of the main coil. This meticulous disassembly is crucial for isolating the specific parts we'll need for our project. I'm gently pulling apart the motor housing. You can see the various components inside: the stator with its copper coils, the rotor, and the front and back covers. The goal here is to carefully separate its components so we can repurpose the central part and the casings. We'll be focusing on the stator for this project. Here's the stator, the stationary part of the motor that contains the wire coils. I also have a small piece of PVC pipe, which I'll measure to fit perfectly within the stator's central opening. I'm drilling 2 small holes into the PVC pipe. These holes are crucial because they will allow us to neatly thread the new antenna wire through and secure it as we wind it. With our prepared PVC pipe, I'm now taking some red electrical wire. I'll carefully thread one end through a hole and begin winding the wire tightly around the pipe. This process is creating our first inductive coil, which will be a key element for picking up broadcast signals. The more turns, the stronger the potential signal, so I'm putting in a good number of wraps. To insulate the newly wound coil, I used black electrical tape to create an insulating layer for the new coil. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Next, I took the white insulated wire. I carefully stripped a piece off one end and twisted the exposed copper core into 2 small pieces of wire. This made for a more secure connection. I then wrapped it around the fan motor stator, threading it through the existing slots. It is important to keep the coils even and tight for optimal performance, as this will directly affect the signal reception. Then, I'll connect another white wire to the opposite side of the stator, completing this part of the circuit. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. It's time to put the motor back together. I'm carefully placing the rotor and covers back into position, making sure all the wires are tucked in neatly so they don't get pinched. I'm carefully placing the coiled PVC pipe into one half of the motor casing. I will then align the stator and join the two motor housing halves together. This step is about securing the newly created coils within the original motor housing, setting the stage for our antenna. I'm using a screwdriver to refasten the screws that hold the motor casing together. This firmly encases our internal components. I'm also ensuring the red and white wires are neatly routed and not pinched, ready for their connections later. We want a robust and compact unit, so a snug fit and proper wire management are important for longevity and performance. Next, I will prepare the red and white wires of the motor. Using pliers, I strip the outer insulation to expose the copper wires in preparation for connection. I'm connecting the prepared white and red wires to a small terminal block. This keeps the connections neat and tidy and is essential for a safe and stable circuit. For stability and a clean setup, I'm mounting our repurposed motor assembly onto a small piece of wood. I'll securely glue the motor assembly and the terminal block onto this wooden base using hot glue. This provides stability and keeps everything in its place while it's in use. This wooden base provides a non-conductive and sturdy platform for our antenna, preventing short circuits and making it easy to position. Now, I'm drilling holes into the wooden base, near where our wires will connect. These holes will hold screws that act as additional connection points for our signal boosters. Next, using an angle grinder, I'm trimming the tops of these screws. To further secure the connection points and make them adjustable, I'm adding washers and nuts to the trimmed screws, creating robust terminal posts on our wooden base. These posts will provide secure points for our antenna connections. I'm now taking the end of the white wire from our coil and attaching them to this metal screw. I'll wrap them securely around the screws and then tighten them down with a screwdriver, ensuring a strong electrical bond. After securing the wire securely, I added a nut to this screw. Then, I'll strip and attach the red wire to the other set. One end of the red coil goes to one screw, and one end of the white coil goes to another, completing our internal circuitry. Here's where it gets interesting. I'm taking two nail clippers and attaching them to the remaining free ends of the screw, using the nuts as connection points. The metal of the nail clippers will act as additional elements, effectively extending the antenna's surface area to capture a wider range of frequencies. I'm using small screws to firmly secure the nail clippers in an open position on the wooden base. This ensures they maintain their shape and position as part of our antenna, maximizing their ability to pick up signals. They're like little rabbit ears, but with a DIY twist, designed to be stable and effective. Here I have a standard coaxial cable. I'm preparing a coaxial cable by carefully stripping back the outer jacket and exposing the braided shield and the central conductor. The center conductor will connect to one side of the terminal block and the braid shield to the other side. A secure connection is essential for optimal performance. I'm preparing the other end of the coaxial cable by stripping it in the same manner. Then, I'm attaching a screw-on F connector to the cable, followed by a right-angle adapter. This combination makes it easy to plug the antenna directly into the TV's input, especially in tight spaces, ensuring a secure and efficient connection. It's time to test its effectiveness. Before plugging in our homemade antenna, the TV shows no signal. I'm trying to use the remote to change channels, but nothing happens. This confirms the TV isn't receiving any signal. I'm plugging the coaxial cable into my TV. And just like that, we have a signal. Look at that crystal clear picture. Our simple DIY antenna booster, made from a fan motor and nail clippers, is working perfectly. I can scroll through channels and enjoy my favorite shows without any interference. As you can see, the screen is now showing clear, crisp channels where before there was no signal or a very weak one. I can now change channels freely, and each one comes in crystal clear. This is the power of our simple, homemade antenna. To really show you the difference, I'll disconnect the antenna. See, no signal immediately returns. But once I reconnect it, bam! Instant channels. It's working exactly as intended. The TV instantly comes back to life, showing clear channels once again. An effective, homemade TV antenna crafted from an old fan motor. This project proves that with a little creativity, you can transform everyday objects into something truly amazing and useful. If you enjoyed this unexpected transformation, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other surprising DIY projects you'd like to see. Thank you for watching, and I'll see you in the next one.